Hello everyone, here's another probability video. This one is on tree diagrams. What is a tree diagram? Well, it's a way of showing you probabilities visually. It's called a tree diagram because it looks a bit like a tree. Only a bit, don't get too excited. How do you use one? Well, this is probably the most useful thing. If we read a question and have a go at answering it. So, in this example, there are 4 yellow balls and 5 red balls in a bag. One of them is chosen at random and then put back, and then we choose the second one. What is the probability that both balls are yellow? Well, what we have here is a tree diagram with no markings on it as yet. This fork here represents choosing the first ball. Now, when we choose the first ball, it could be either yellow or red. The chances of it being yellow, well, count how many yellow balls there are. There are 4. And count how many balls there are altogether. 4 add 5 is 9. So the probability of it being yellow is 4/9, which I write there. The probability of it being red is 5 chances out of 9, and I put that here. Having chosen one ball, let's imagine that we came along this path and we chose a yellow one. Now at this point we choose a second ball, and again it could be yellow or red. Now because we put the ball back, it doesn't change our probabilities for the second choice. So still, the probability of a yellow ball is 4/9, and the probability of a red ball is 5/9. But we might not have come to here. Our first ball might have been red, so we might have followed this path instead. And still, when we choose a second ball, it could be yellow or it could be red. And still, the probabilities are 4/9 and 5/9. Now, we've got 1, 2, 3 forks here. 1 fork to represent choosing the first ball, and 2 forks to represent choosing the second ball, because we might be choosing a second ball after initially getting a yellow, or we might be choosing a second ball after initially getting a red. But on all 3 forks, notice that when you add the probabilities together, 4/9 add 5/9, you get 9/9, which is 1, because what we've got here represents all the possibilities. So it is certain that we get a yellow ball or a red ball. So these probabilities must add up to 1, and that will be the case everywhere on every tree diagram, that all the probabilities on that fork add up to 1. Right, so I want the probability that both balls are yellow. Now, if I follow the paths which get me to that, I would go along here and then along here. I would have a yellow ball followed by a yellow ball. So that means ending up at this point here. And I will write P bracket Y, Y, using the notation we've used before to say the probability of getting a yellow followed by another yellow. And what do? We multiply 4/9 by 4/9, and that gives us 16/81. So that is the answer to our question. The probability of 2 yellows, writing it slightly differently, is 16/81. And that's the answer to the question. Now, we're not asked to do anything else, but it might be useful to carry on. What if I followed this path followed by this one? That would get me a yellow followed by a red. And the probability of that is 4/9 times 5/9. and that is 20 over 81. Okay, because remember, multiplying fractions, we multiply the numerators together. 4 times 5 is 20, and we multiply the denominator together. 9 times 9 is 81. I might follow this route. So I might have a red followed by a yellow. What's the probability of that happening? 5/9 times 4/9. And that gives me 20 over 81. Or I might finish up here. So I might follow that path and have a red followed by a red, and that gives me 5/9 times 5/9. And that gives me 25 over 81. So that is the probability of all 4 arrangements of choosing 2 balls from the bag. Notice the probabilities here are 16 over 81, 20 over 81, 20 over 81, and 25 over 81. If we add these up, you get 25, add 20 is 45, add 20 is 65, add 16 is 81. That's 81 over 81. Again, it is 1. All of these probabilities also add up to 1, because it's certain that if we choose 2 balls from this bag, we get 2 yellows, or a yellow followed by a red, or a red followed by a yellow, or 2 reds. So these must add up to 1 as well. Now, we could ask something a little bit more complicated. We could say, what is the probability that the balls are the same colour? Well, that would mean that I finished up either here or here. Same colour, yellow followed by a yellow, so I finish up here, or a red followed by a red, I finish up here. So what are those probabilities? Well, 16 over 81 add 25 over 81 gives me 41 over 81. The probability that the balls are the same colour. What's the probability that they are different colours? Well, that would bring me to here or here. Yellow followed by red, or red followed by yellow. And that is 20 over 81 add 20 over 81, which is 40 over 81. Notice again, if I add these together, I get 81 over 81, which is 1. It's certain that if I choose 2 balls from the bag, they'll either be the same or they'll be different. So that's all the possibilities. These probabilities must add up to 1. That's a tree diagram. Right, here is an example for you to have a go at. Have a go, see how you get on, and then when you start the video up again, I'll show you how I did it. Right, so first choice is either a yellow or a red, and the second choice is either a yellow or a red, yellow or a red. Now, when I choose that first ball, it's 3 chances of being yellow, 5 chances of being red. So the probability is 3/8 yellow, 5/8 red. And that will be the same here, and here, and here, and here. Okay. Probability of 2 yellows, 3/8 times 3/8 is 9/64. Probability of a yellow followed by a red is 3/8 times 5/8 is 15/64. The probability of a red followed by a yellow is 5/8 times 3/8, which again is 15/64. And the thing we're asked for, the probability of 2 reds, is 5/8 times 5/8 is 25/64. Let's check what we've got here. 25 add 15, that's 40. Add 15, that's 55. Add 9 is 64/64. These do add up to 1. That suggests to me that I'm right. So the probability of a red followed by a red is 25/64. What's the probability that they are the same? So that's 2 yellows or 2 reds. That's going to be this here, 9/64. Add this here, 25/64. That gives me 34/64. What's the probability that they are different? Well, that brings me to here or here. So that's 15/64. Add 15/64. And that is 30/64. And again, these two answers here add up to one whole one. Okay, 34 add 30 is 64/64. All right. What would we say in our summary? Well, first of all, that the probabilities on each fork add up to 1. Secondly, multiply all the probabilities along your path. So in ending up here, I cross 2 probabilities, 5/8 and 5/8, and I times those together to get the probability of ending up at that end point. And lastly, add up probabilities at the end for combined events. So if I say to you, what is the probability that the balls are different in colour, or I say, what is the probability you get 1 red and 1 yellow, that means that you end up here or here, so we have to add those 2 probabilities together. All right, have a go at the questions on Maths Watch or in the PowerPoint. Let me know how you get on. Bye.